So this is the seventh session on rigid body on the Newton's laws of motion. This is also in continuation of the sixth video. So in this also I'll take up numerical problems on Newton's laws of motion. Okay. Generally based on integration based questions I'll take up. Fine. So I'll write down the question first. So I'll write down the working formula. Net force on the particle is equals to mass times acceleration. If you want to write down the equation of motion of point along x direction, fx dash minus f double dash, that is the net force, x component of net force on particle, that is this minus this, max, and similarly for y and z directions. Okay. What is f is the net force? Fx dash is what? Sum of x components of all the real forces on particle which make acute angle with positive x axis. And what is fx double dash? Sum of magnitudes of x components of those forces on particle which make obtuse angle with positive x direction. Ax is just the acceleration of point along positive x direction. Okay. So I'll write down the question now. Question is this: a point P of mass m, is initially at rest at L, 0 and is constrained to move along x direction under the influence of a one-dimensional variable force along positive x direction and given as f equal to m lambda by x cube. Here m is the mass, lambda is a positive constant. And x is the instantaneous x coordinate of that point P. Question is, find the speed v of the point. Find the speed v of the point at the instant its x coordinate becomes 3L. Okay, this is the required question. So this is again, see, we have to apply simply, we have to get the speed of the particle when its x coordinate becomes 3L. All we have to do is to apply Newton's second law to point along positive x direction and then integrate the resulting equation to get the required answer. Okay, fine. So what do you do now? I write down the equation. I write down the equation in vector form. Fx be the net force on particle along x direction, that is equals to mass times acceleration along x direction. So this Fx is the x component of net force on the particle, and that is Fx dash minus Fx double dash Ax. Okay. Now what is Fx dash? The sum of x components of those real forces on particle which make an acute angle with positive x axis. On this problem, only one force acts on particle along positive x direction. So that itself is Fx dash. This F itself is Fx dash. I write it m lambda by x cube. What is Fx double dash? Fx double dash is the magnitude of sum of magnitudes of x components of those forces in particle which make obtuse angle with positive x direction. In this case, only one force acts on particle along positive x direction. There is no force on particle which makes obtuse angle with positive x axis. So Fx double dash becomes 0. Now Ax will be written as dVx by dt. Now m and m will go away. Okay, these two cancel out. Fine. Now rub this one. Now you have to find Vx. So I write this in chain rule as this way: dVx by dx into dx by dt from chain rule. Dx by dt becomes Vx. This becomes Vx dVx by dx is equal to lambda by x cube. Now shift dx that side. Vx dVx becomes lambda dx by x cube. Okay. Now I integrate this equation on both sides. Initially x was L, finally x becomes how much? 3L. When x was L, point was at rest, so Vx is 0. And when x coordinate becomes 3L, Vx becomes Vx. Now integrate and inserting limits. Left side, what do we get? Vx square by 2 is just equal to lambda is constant, dx by x cube L to 3L. Lambda 1 by minus 2, and this becomes x power minus 2 L to 3L. Okay, so this becomes 2 goes away, minus lambda, this becomes 1 by 9L square minus 1 by L square. This becomes 8 lambda by 9L square. This becomes Vx square. Okay. So this means Vx is how much? 8 lambda by 9L square. But see, we have been asked to find the speed. But movement is along x-axis. So y and z components are of velocity are always 0. So Vy is also 0 always and Vz is also 0 always. Only Vx is there. Is it clear? I rub this one. So if I rub this one, what do we get here? So Vx is, Vy and Vz are always 0. Vx is this. Speed V is simply root under Vx square plus Vy square plus Vz square. This is 0, this is also 0. Only root Vx square remains, that is Vx. So speed V of point at that instant becomes a root under 8 lambda by 9L square. This is therefore the required answer. Okay. So V becomes how much? Root under 8 lambda by 9L square. This is the required value of V. Alright, fine. I take up next question on this session. See, other question is this. Particle P of mass m is initially at rest at 3L, 0 and is constrained to move along x-axis under the influence of a one-dimensional force along negative x-axis. Along negative x-axis and given as f equal to m lambda x square, where lambda is a positive constant. Okay. Now rub this one. This force always around negative x direction. Okay. Question is this: find the speed of particle when its x coordinate becomes L. Okay. This is what you have to find. Okay. So how to solve the question is the answer, is the problem. See, first I draw the situation. This is x-axis, this is y-axis. This is the origin of coordinate system. Point P is initially here at time 0. Its x-coordinate is 3L. It is constrained to move along x-axis under the influence of a one-dimensional force F, which is always along negative x direction, and which depends on x-coordinate as m lambda x square. Suppose the point is somewhere here. Force on the particle is always along this direction, and it is at rest. Since force on particle is always along this direction and it is at rest, so when released from rest, it will move towards leftward direction, in negative x direction. Okay. That's when it moves, and finally when its x coordinate becomes L, its speed becomes v naught. Say this v naught we have to find out. This v naught we have to determine. Okay. Now suppose at some arbitrary moment point P is here. Okay. Its x coordinate is say x. Its speed is say v. Okay, fine, all right. So now what do? We apply, the point is moving along negative x direction. Okay, I apply Newton's second law to point along positive x direction. So what do I write down the equation as? Fx dash minus fx double dash is equals to n times ax. Now what is fx dash? Fx dash is the sum of x components of all the real forces in particle which point along positive x direction, which make acute angle with positive x direction. Now there is only one force on point P, that is along negative x direction. So there is no force on particle which makes acute angle with positive x direction. So this term becomes 0. What is fx double dash? It is the magnitude of sum of magnitudes of x components of all the real forces on particle which make obtuse angle with positive x direction. There is only one force on particle which is negative x direction. So this makes an obtuse angle of 180 degree with positive x axis. So fx double dash becomes simply n times lambda into x square. And what about ax? This becomes dv by dt, dvx by dt. And as in the last question, it becomes mvx dvx by what? dx, as in last problem. Okay, fine. I love this one. You can see from this equation m and n will go away. So what do we get? We get Vx dVx by dx is just equal to minus lambda x square. So Vx dVx becomes minus lambda x square dx. Okay. So now integrate this equation on both sides. Minus lambda x square dx. Okay. Initially x is what? 3L. Finally x becomes L. Initially Vx is what? 0. And when it becomes L, Vx becomes Vx. Alright, fine. Now I rub this one, okay? This becomes how much? On integration, this becomes in exotic limits. Vx square by 2 minus lambda. This becomes lambda by 3x cube. This becomes L cube minus 3L whole cube. Okay. So this becomes Vx square becomes 2 lambda by 3 into L cube into 26. 27 minus 1 minus 26 minus 1 plus. So this becomes 52 lambda L cube by 3. So Vx becomes 52 lambda L cube by 3. This is what is Vx. And since movement is along y and along x axis, there is no motion along y and z axis. Therefore, Vy is Vz equal to 0 always. So speed V is simply Vx. Root under Vx square plus Vy square plus Vz square. Vy Vz are both 0. Root Vx square becomes Vx. So this becomes 52 lambda L cube by 3. Is therefore the required answer. Okay. So speed of particle when its x coordinate becomes L is simply root 52 L cube by 3. I hope it is clear. Fine. Alright. I love this one also. Fine. I take up one more question in this video. Now third question of this video I take up. Third question. of this video, third question I take up. Third question. Okay. The third question is this. Third question says that suppose a particle P of mass m is initially at rest at L comma 0. No, is initially at L comma 0 and is given an initial speed of v naught along positive x direction. Along positive x direction. This particle is subjected to a one-dimensional force F along negative x direction and depending on x coordinate x as F equal to m lambda x cube. Here lambda is a positive constant. Okay. Write up this one. Question is, find the value V naught so that P momentarily comes to rest at 2L comma 0. P, particle P, momentarily comes to rest at x equal to 2L. Okay, fine. This is the situation. Okay. So how to solve this problem? That is the question. How to solve this problem? Okay. See. Question is this. See, I draw the x-axis. Okay. This is the x-axis. This is the origin. Particle is initially at this location. Its x coordinate is L. It is given rightward speed v naught along a positive x direction. It is subjected to a force F which is along negative x direction, which depends on x coordinate of the point as m lambda x cube. M is the mass of point. So what will happen? See, force on particle is acting towards leftward direction. It is given rightward speed. Since velocity and force are in opposite direction, as it moves ahead, its speed goes on decreasing. Finally, when x becomes equal to 2L, its speed v becomes 0. Its speed v becomes 0 when its x coordinate becomes 2L instantaneously. When its x coordinate becomes 2L instantaneously, its speed v becomes 0. So you have determined the value of v naught, so that is this condition is fulfilled. So how do we proceed to solve this problem? To solve this question, what we do? We apply Newton's second law to point along positive x direction. See, one thing I'd like to make it clear. In this problem, P is moving along negative x direction. It is moving in a rightward direction, but it is accelerating towards leftward direction. Is it alright? Its motion direction is rightward, but net force on the point is leftward. They are in opposite direction. And applying Newton's second law to this point along positive x direction, I am applying. Okay, fine. So I apply Newton's second law to particle along positive x direction. So net Fx with the net force, x component of net force on particle, that is just equal to Fx dash minus Fx double dash, that is just equal to m times Ax. Now what is Fx dash? Fx dash is the sum of x components of those real forces on particle which make acute angle with positive x-axis. But there is only one force on F on P which is along negative x direction. So there is no force on point which makes acute angle with positive x-axis. So this term goes away. What is Fx double dash? Fx double dash is the sum of magnitudes of x components of real forces on point which make obtuse angle with positive x-axis. Only one force F, this makes 180 degree with positive x-axis. So this force makes 180 degrees. So this is 0. This just becomes f itself. And ax we write again as dvx by dt. This is how we write ax. Fine. All right. So ax will be written in this way. Ax will write as dvx by dt. Okay. Fine. Now add up this here. Okay. So I write here m dvx by dt becomes minus m lambda x cube. M goes away. This one chain root, this becomes vx dvx by dx. This becomes minus lambda x cube. Okay. Now shift dx that side. Vx dvx becomes minus lambda x cube into dx. Alright, fine. So this becomes this much. Now I integrate this equation. Lambda x cube dx. Okay. Initially x coordinate was how much? L. And finally x coordinate becomes 2L. Initial velocity was v naught. And when it comes to rest at 2L, v becomes 0. Upper limit of vx becomes 0. So this becomes, on integration and inserting limits, this becomes minus v naught square by 2. This becomes minus lambda by 4. X power 4 it becomes, on integrating, L to 2L. So this becomes v naught square equal to lambda by 2. This becomes 16L power 4 minus L power 4. This becomes 15 lambda L power 4 by 2. Okay. So v naught becomes square root of this quantity. Fine. I love this one. So on simplifying it, v naught becomes root under, this becomes how much? 15 lambda L power 4 by 2. L power 4 by 2 is therefore the required answer. Fine. Alright. So this was the third video of this 7th session. Okay. Third question, a numerical example of this 7th video. Okay. So next video also I'll take up some more problems on integration and Newton's law based problems. Okay. So this I close it here. Fine. Again, if you have any doubt, you go through it properly. If you have any doubt, you write down your doubt in the comment box. I'll look at it and rectify it. Fine. So this I close it here. Fine. Alright.